So where we left off was we have this game, and for me, babies are spawning. Cool. Let's make the spawner work properly now. So you guys all should have already done this. So let's go to the spawner, and I'm going to go to the blueprint, and let's just have it spawn something when the level starts. So we'll do a begin play. We'll have it create a spawn actor from class, and we'll pick our falling object here. And then transform is just going to be get actor transform, compile, and this will spawn one thing when the level starts. Okay, how about we spawn something every X number of seconds, okay? So what we want to do is after we spawn one of these guys, we want to spawn another one. So what we can just do is pull a wire off of here and put a delay in between this spawning one and spawning another. So I'll put a 1 second delay. And I'm just going to have it plug right back into spawn actor. So the end of the delay plugs into spawn actor like that. So now what will happen is that every second, babies will drop. Okay, do you guys see what I did there? I just put a delay, and then after the delay, I just plugged it in. I like that. That's good. Okay, so really simple. We're going to do more with this because this delay here needs to change based on how hard the level is, right? So if I made it like 0.2, the babies will spawn much, much faster, which will make it so that much, much harder. Okay, so a couple of things. One, the babies are colliding with each other, right? We don't want that. And two, the babies are kind of falling into the level, into the scene. So let's just make the babies not collidable at all. So I'm just going to go to my falling object. And we're going to, because the babies don't need to collide, they don't actually need to have like collision at all. I'm just going to go to the static mesh here on the baby, and instead of setting it to be a physics actor collision preset, I'm just going to have it have no collision whatsoever. It'll still rotate and it'll still fall.
Where's that at?
If you click on the mesh and go down to collision, there's a collision preset that you can pick. Where it says physics actor, pick no collision instead. And that way, when the babies are falling really, really fast, they will not have collision. Oh, one more thing. Yeah, so changing them to do that, I think also, unfortunately, makes it so it doesn't fall. Kind of sucks. Let's just do this. It'll be a physics actor. The only weird thing is that this shouldn't have done that. No collision enabled. Let's see what happens here. No collision. Let's try this. Sorry, it's actually colliding with something, or it's not falling out of the sky. Let's just see which one of these. Oh, the babies are up there. They're actually up there. They're just not falling. Yeah, this is new. Let's see. Collision, physics body. No collision is performed against this body. Simulating physics. Let's try this. Let's try no physics collision. Okay, that seems a little bit better. All right, yeah, sorry, some of these properties have changed since I last used this. So if you go to your components, if your babies aren't falling, try this. Click on your mesh and scroll down to where it says collision presets. And instead of doing no collision, do custom. And just where it says collision enabled, do no physics collision. and change the object type to be physics body.
Physics body?
Yeah, physics body. Doesn't mean it'll still react like a physics body, it just won't have the, because it has no physics collision, it won't fall into one another. Okay, I think we get the point. Let's make, so what's missing still from the gameplay?
Splatter when they hit the ground.
You know, splatter when they hit the ground? Let's worry about the splatter next. Well, aside from that, what gameplay features are missing?
The spawner doesn't move.
Spawner doesn't move. Okay, so let's make the spawner move. So normally when we've had to move things before, we've used either matinee or a timeline, like elevators, right? This is a little bit different because this movement here is dependent upon, it has a chance to like reverse direction, and it also is supposed to reverse direction when it hits like the side walls. And because of that, we can't really use a timeline. Timelines are really meant for play once or maybe reverse, but not for like change directions quickly. Yeah, so we need to set up something that lets us move in a direction and then change directions based on how, in this case in Kaboom, it's a 10% chance after you spawn something whether you should move or not. So before we even get to that, let's just set up something that lets us move this guy left and right, right? Like, here's my thing. I just want it to move like this, right? I just want to move left and right. So what am I actually doing here to the location? What value over there on the right is changing?
Changing the Y.
Y, right? Yeah, so like, it's actually, the faster I change it, the more it goes. But like, if I even move this slowly, it's changing by like 10 every so often, because I have the snap turned on. If I turn off the snap, it's changing by a lot less, right? Maybe by like floating points. So we kind of need to do that. We kind of need to be, we need the game to be the mouse cursor, to drag this thing left and right, okay? So what that means is that we need to change the Y position here based on when the game is running. So when the game starts playing, it's going to basically change, it's going to add to Y when the game starts, okay? So how about we just start off with something simple, like, hey, how about every second, let's just move it 10 units in Y, or maybe even 50 units in Y, okay? So like every 1 second, let's just move it in one direction. Hell, let's just say that every time after it spawns an object, let's just move it in Y 50 units negative. That's like the simplest thing we can do, right? We have the spawner, and it's already spawning an object, and it has this delay here. How about right after the delay is done, let's just move it, let's just subtract 50 from the Y, okay? How do we subtract 50 from the Y position? Well, we need to get the current position of where it's at, and then we need to subtract from the Y, and then we need to move it. So we can add an offset to it. So if I drag a wire from here, I can do an add actor offset, and I can add a delta to the location of this actor in world space, which is what I want. And every time it spawns, let's just move it in Y, minus, let's do 25. That might be a little bit better. So every 1 second, it's going to move 25 units to the left. So add actor, world offset. Okay, you guys got that? Now play it. And what you should see is that your babies start moving in Y very slowly. And if you want to see a little bit bigger, maybe move it in positive. For me, positive 100 will move it to the left, while negative will move it to the right. So you can see here the babies are actually moving very slightly, right? Let's do one more thing, because I kind of want to see the movement of this. I'm going to go to my spawner, and I'm going to go to my billboard. I'm going to make it visible in-game by unchecking this checkbox, the rendering checkbox, because I want to see it moving in-game. And I'm going to lower the spawner so that it's low enough so I can actually see it. Can you guys see that little spawner guy up top here? The little dragon head that's moving? If you don't see it, go to your spawner, Christian, Oh, here. Can you compare your blueprint to this guy? Should be add actor world offset. Because we're going to change the movement behavior a little bit too. Because we want the spawner to actually have a mesh on him, right? Let me just go ahead and make a mesh for the spawner for now, because I want to just see him in game. I'm going to use, I don't know, I'm going to just use a cylinder for now. I know it's not as exciting as the baby.
Why can't babies just fall out of the sky?
Well, they could, but for me, I'm trying to demonstrate a point here, which is that, can you guys see that the cylinder is like...
Horrible.
Can you guys see that it's basically teleporting? Like every time it moves, it teleports to the spot, right? You remember the Kaboom? Even Kaboom, it didn't teleport to the spot, right? So why is it teleporting? How do we get it to move smoothly from one spot to another? Well, it should be obvious why it's teleporting, right? Because we're just adding 100 to it every time it spawns. But I don't want to just add 100. What I want to do is I want to move in a direction over time. So think back to physics again. You guys understand the concept of velocity, right? What velocity means and how velocity changes what your position is. Like if a ball is thrown from here to here, the velocity in this direction is going to be, let's say, 100 miles an hour. Miles per hour. What does the velocity of 100 miles per hour mean? How fast does that move? It means it moves 100 miles in 1 hour, right? If I have this thing set up so that I want a spawner that moves, I can specify a velocity of how fast it moves. Let's say I want it to move from here to here, that is 100 unreal units, and I want it to move it over 1 second. What does my velocity need to be if I want to move it from here to here? 100 units a second, right? What if I want it to move from here to here, same distance, in 0.5 seconds? What's my velocity got to be? Half a second, right? What's my velocity going to be? I want to move in half the time. Let me go back to the level here. I have it here. It's at negative 250. I want it to move from here to negative 350 in 1 second. Okay? What's my velocity got to be in units per second? 100 units per second. If I want it to take 1 second, it's got to move kind of like this. Right? 100 units per second. That's 100 units per second. If I want to get there in half a second, how fast does it have to move? 200 units per second, right. If I want it to take 2 seconds to get there, it would be 50 meters per second. So the point that I'm trying to make is that you have this concept of velocity that can be used to control movement over time. If I want this thing, the spawner that starts here, to take, let's say, think about how fast a Kaboom one spawned, right? It took from here to here, it was like maybe in 2 seconds it took to move from here to here. So let's see, if I look at a top-down version of this, okay, so here's my top-down version. Here's my, this is my spawner here. Where's my spawner? Over here. Here's my spawner. The distance from here to here is about 1,400 units, let's say. maybe a little less, maybe like 1,300 units. So what I want to do is I want to move him using velocity instead of just teleporting him. And how do I do that? What is distance equal to? Velocity times time. Distance equal to v times t. Do you guys remember this at all? Does this sound familiar at all? You guys don't know? You know that the distance that you travel is equal to how fast you travel over how long you travel that speed for, right? Like if I tell you throw a baseball at 100 miles an hour and it moved for 1 hour, how many miles did it travel?
100.
Right. That's because 100 miles an hour over the unit of time times 1 unit of time is equal to 100 miles, right? If you throw a ball at 100 miles an hour and you travel for 2 hours, how far are you going? 200 miles, right? If you throw a ball at 100 miles an hour and you travel for 3 seconds, how far do you actually travel? So 3 seconds is, right, 3 divided by 60. That's 0.05 minutes divided by 60. That's this many hours times 100. You travel 0.083 miles. Okay. So this formula can be used even if your unit of time is 3 seconds, right? So the reason why this formula is important is because if we specify velocity and we give it time, we can get a distance for how far it should move for that time. So if this is what we want to tune for our game. This is how we tune our speeds as well. Like how fast characters move in Overwatch, how fast bullets fly in Overwatch. It's all based on velocity. We tune based on velocity. We know how fast we want this thing to move, and we just say go. Now the thing is that right now, what is our velocity here actually? We actually have a velocity. What is it? 100 units every second. That is our units. The only difference is that we're teleporting it every second. So what we can do instead is we can find out if we pass in our own time, we keep the velocity constant at 100 units per second. And instead of moving it 100 units every time, why don't we move it all the time? And we'll just move it a little tiny bit every time. So instead of moving it once every second, we're going to move it all the time. So just like this. We're going to just kind of move it at little tiny bits. Like how this is moving 10 units at a time, that's what we're going to do too. So let's just try this as a test. I'm going to have you guys disconnect the add actor world offset from the delay and just reconnect the delay back to spawn actor so it's spawning something every second. We're going to use a tick to do this. So let's make a tick event, and the first thing I just want to do is I'm just going to print out the delta seconds on tick. Now remember I did this before. The delta seconds on the left there, that's how much time has passed since the last time I called event tick. So all these little numbers on the left are how many seconds have passed. So let's just do something as a test here. Let's just connect tick to here. And what do you think will happen if I press play right now? It's going to move 100 units in Y every tick. There it goes. That is super fast. So this thing here is actually moving at a rate that we're not sure. If I move this thing, let's just say I move it, I have a delta of 1 here instead of 100. See how the movement there? It's actually moving 1 unit every tick. So I'm going to kind of talk a little bit about a tick here. Let's say we have 2 computers. Let's say I have a shitty like 4-year-old computer. And then let's say I have a top of the line like really high-end computer here. And this guy here, he runs the game at, let's say, 30 frames per second. And this guy here runs it at 120 frames per second. Okay? Let's say we play the game for, let's just say the game has been running for 1 second. How many frames have run here? How many frames have been rendered here?
50 total.
Well, in 1 second, this guy? 30 frames have been rendered here. What about in 1 second here? How many frames have been rendered? 120. Okay. So in the high-end computer, 120 frames have rendered, while the low-end computer has only had 30. Okay, does that make sense? Like, you know, you play games, if your computer can't quite handle it, you know how the game sometimes runs slower? Well, the frames per second, actually, this number here, the 30 over here and the 120 over here, is exactly how many times this thing will run in that same time period. So on my machine here, my machine that I'm running that's connected to the projector right now, I might get about 30 of these in 1 second. Michael, you might get like 32 or 26. Or if you're running it on a home computer, this might be like 300. You might get 300 of these in 1 second. But what are we doing here? We're moving it 1 unit every time this is called, which means that the amount that our spawner moves is actually completely dependent upon how fast our computer is. So if you run this, like, okay, so how many times will our spawner move on our 4-year computer? It'll move 30 times, right? It gets called, does that make sense? Like it's moving 31 units. So it starts here, moves a little bit, starts here, moves a little bit, starts here, moves a little bit. It does this 30 times, okay? How many times does it do that over here?
120.
Okay, so it's going to do 120 units. It's going to move 120 units to the left.
4 times faster.
It's going to move 4 times faster just because it's a faster computer. If I ran this on a potato, I might get 1 frame a second, which will mean that I'm going to play the game for the same amount of time. I'm going to give you guys an hour to play this game. If you're playing it on a potato, you are physically not going to actually get the same amount of gameplay as I am. The game's actually just going to run faster, right? Yeah, it'd be easier, totally. You ever play like, that's how it was in the old day, like there were games that would run slower and it'd be easier. So we can compensate for that here. The way we can compensate is by using this guy right here. This delta seconds tells us how slow or fast our computer is actually running right now. Okay? This tells us how much time has passed since the last time the frame has been called. Now, I won't get into the specific details of what this is with regards to the frames per second, because it's basically 1 over the frames per second. This delta seconds is going to be bigger on a slower computer. If I'm running this on a potato and I only get 1 frame a second, this is going to be 1. If I'm running on a good computer and I'm running at 60 frames per second, this is going to be 0.1, okay? 10 times faster, or 60 times faster. Yeah, 1 over 6. That's 1.016, I think. 60. Yeah, 0.016. This is going to be 60 times faster. So what we can do is we can take this guy and we can actually use him for our delta location. So first thing I want to do is I'm going to take this delta location. I'm going to split the struct. And I'm going to use delta seconds here to figure out what our velocity should be. I could just plug it into here, but that's actually going to be super slow. Can you guys tell that that's actually moving?
Yeah.
Would you believe me that it is moving?
Yeah, it's past the equator now.
Yeah. So that's actually correct. That thing is moving at 1 unreal unit every second. That's how fast it's moving. That is our velocity. What do we say our velocity was? The distance, it was like 1,300. If I want that thing to cross in 1 second, I'm going to just multiply this delta seconds, by a float. And this float here, this number right here, is going to be our velocity. Okay? So if I want my velocity to be 1,300, which means cross the entire screen in 1 second, I can put 1,300 here and plug it in. And now when I play, it'll span the distance in 1 second. You'll have to believe me when that actually is 1 second, okay? And that's the key, is that this guy is our velocity. So you guys can do the same thing, and I can just promote this to a variable, call it velocity. It's not really velocity, sorry. This is actually speed. This is how fast we want to move. I mean, you can call it velocity if you want. I'm going to call it speed. So it's going to be 1,300, and I can slow this down. If I want it to be 650, it's going to take 2 seconds to cross. Okay. I promoted this thing into a variable. I right-clicked on it, it did promote the variable. Okay, you guys have this too? You should connect this up. Because now that we have a speed, what we can do is we can also reverse the speed when we hit the walls, or sometimes we'll reverse it after we spawn an object too. John, you have this? You get it working? Michael, you good? Christian, how you doing? Did you get this working? Yeah. Okay. So let's set up the behavior where it bounces back and forth in our level when we hit objects. So kind of like how we set up this trigger volume here, we're going to set up 2 more trigger volumes on the sides. So this guy right here, which is our brush, we need, let's first set up a box on our on our spawner. So go to your spawner and let us set up a box. This is going to represent kind of like the bumpers for our spawner. So we can expand this guy, scale him up. And you just kind of want him to be big enough where the sides of the trigger box are going to be able to detect a collision with the walls.
We need a parent the box.
In this case, we don't. You can. It doesn't really make a difference. The reason why we don't need to is because this mesh is not a physics mesh. We're actually moving the entire thing. So first things first, let's just see what happens when we take this trigger and let's hook up an overlap event for that trigger. So let's go here, click on the trigger, and I'm going to generate an overlap event. And I'm just going to print out on overlap what it overlapped with by getting the display name and hooking it up here. And I expect to see a couple of things. One, I expect to see overlapping with our crazy ugly baby, and also I would expect to see it colliding with the BSP. Right, so it's not colliding with the BSP, and that's because our BSP isn't set up to overlap with this event. But you can see here, something to keep in mind, see how in the top left it's actually the things that it's overlapping with are falling objects. Those are the babies. So keep that in mind, that it will have to be, we'll have to set up something similar to what we did for the falling objects. Okay, so let's go back to the map, and let's drag 2 triggers into the level. Actually, I'm just going to do 1, and I'll just duplicate it. I'm going to make this thing super tall, like 800 units tall. Kind of like what you did for the kill volume here. You really don't need it to be that tall, but I'm going to put it inside the BSP geometry as well. And then once you have one of them, just duplicate it and put it inside the other one. There's a lot of different ways you could do this. We could actually make blueprints for the walls as well. We could change the collision on the spawner to care about BSP. For now, we'll leave it at this because I think this is fine. Okay, so once you have your 2 trigger volumes set up, we'll go into the spawner. And now when we're overlapping with something, we know that it's already trying to overlap with the babies, so we need to cast the other actor as a trigger box. Make sure I did that. So go to your spawner, cast it to a trigger box, and all we need to do is reverse the direction of the speed. So we're going to take the speed, and we're going to set it equal to the speed times -1. So that is our behavior for detecting collision with the walls and reversing the speed whenever it hits that. So if I play, now if this was all the game was, it would be pretty boring because you know, it's pretty much only reversing directions. There's not really any gameplay here. And also sometimes I notice that the babies will not spawn because the babies themselves are colliding with the trigger box. So I'm going to actually scale up my trigger here. Make sure your tick is still set up. Your spawner should look like this. Make sure you still have this. When you set your speed, Christian, make sure you actually have a default value down here for your speed. You know, that's why it's important to test after you do every little change. Otherwise, you don't know when it broke. You don't know if what you did was what caused it to break or if it was something else that caused it to break.
What were you doing with your trigger? You adjusted the trigger on the...
Yeah, I was just scaling up the trigger because I wanted it to detect collision with the wall. I was just making it a little bit fatter, like this, just so that, because like sometimes it would be inside the wall and the baby would spawn inside the wall, and then I want to have, the bumpers needed to be a little bit bigger. So see how it's like not quite getting to the edge now, and then the babies aren't spawning inside the wall anymore. All right. So this isn't much of a game. So you guys, for homework, are going to make it into more of a game. So a couple things you have to keep in mind is that if you want to make the player run faster, you have to go and edit his blueprint. So you can go to his blueprint and edit his properties here for his acceleration. Remember how we did this for the Angry Birds one? All these properties I want you guys to tune. And the homework is I want you to do two things. One, I want you to randomly change direction with a 10% chance after you spawn a baby, just like how in Kaboom has. So 10% of the time after you spawn a baby, reverse directions, okay? And then second, every time you spawn a baby, I want you to move a little bit faster, okay? So the speed of this thing is going to go a little bit faster every time, okay? Does that make sense? So reverse directions 10% of the time after you spawn a baby. And every time you spawn a baby, I want you to increase the speed a little bit. You can increase the speed by however much you want, but I just want the game to get a little bit faster over time, okay? And then next week, we'll handle lives, we'll handle spawning the babies faster, as well as dropping the babies faster, and we'll handle score as well. All those things you guys all know how to do, believe it or not, but we'll work on it together. All right, that's it.